This is video 662, and the goal of this video is to understand how to perform operations with vectors and to write a vector in terms of its magnitude and direction, because that's going to be more beneficial to us in the long run because it's more applicable. So we're going to talk about those two key things today. And the first thing that we're going to look at is operations. So first of all, if I'm adding and subtracting vectors, so I'm taking vector v and I'm adding vector w, v plus w, what does that mean? So I'm putting two vectors together. Now remember, v is some vector with direction and length, direction and magnitude, and I'm adding on vector w. And let's say w is slightly different direction and shorter. Now if I'm adding these two vectors together, the resultant is always connecting them together like this. So keeping the direction, and the resultant vector is here. Now what that does is, in the end, we're simply adding the two x directions, the x sizes. Now remember, that's the I values, so we're adding the a's together to figure out how far to the left. That's the a1 plus a2. And then we're going to add the b1 and b2 as well, and that's the vertical direction to help me find my resultant vector r. So it's somewhat logical, but you have to understand what a vector is, and that's the issue. If you don't know what a vector is, you won't be able to add them together. And subtracting, again, is logical. You're going to subtract the a values, and that'll be the resultant a value for I. And then we'll do the same thing with the b's. When we're subtracting two vectors, that's v minus w. So I think it'll make most sense when we see this in a example to make sense of it, but it's kind of like adding like terms. That's the way you want to think about it. We add the i's together, we add the j's together. Now, a scalar multiple is the next piece that you need to understand. A scalar multiple basically scales up the vector. So if I'm doing k times vector v, and I'm multiplying some number k times vector v, I'm going to scale up the vector, and it's going to get larger. And what happens is, if I take this vector and I scale it up, the direction doesn't change, but if I times this vector by, let's say this was vector v, and I was timesing it by 2, so I was doing 2 vector v, it would literally make this twice as long. But it would not change its direction. And so all it does is it doubles, or it changes by k both the values. So kv would be k a I. Sorry, I'm forgetting which ones comes first. I before j. I. That's how many i's I'd have, plus k b j. So I times the k times the a and the b. It's like distributive. So it's interesting. It does follow some basic properties, but again, it's because of what's actually happening visually. So let's take a look at this in action. So if I have vector v and vector w, I'm going to find v plus w. All I do is I'm going to add these two vectors together, and you literally add like terms. So I'm looking for 2 plus negative 1, and I get 1i. Negative 3 plus 4, 1j. That's the resultant vector when I add those two together. V minus w. So now I'm subtracting the two. So I'm going to do 2 minus negative 1 for the I value. 2 minus negative 1 is 3i. And for j, I'll do negative 3 minus 4, because this was positive 4. So negative 3 minus 4 would be negative 7j. All I did was subtract like terms, basically. So it's very logical, but sometimes things don't follow normal logic on what we normally do with operations, so it's really important to make sense of what's going on here. We're kind of going backwards by the vector w, which is why we go backwards by the a and the b value. 2v, that's a scalar multiple, so that means I'm going to do 2 times v, which was 2i minus 3j. So it really does double each piece, so it's going to be 4i minus 6j. And that's the resultant vector. Negative 3w negative 3 times w would be negative 3 times negative 1i plus 4j, which is 3i minus 12j. So this actually changes its direction because it's a negative scalar multiple. It will swing it in the opposite direction of what it normally was doing. Good things to keep in mind. Now, what if I'm doing 2v minus 3w? Well, thankfully, I've actually already found 2v and negative 3w. So really, I'm just going to be putting these two pieces together. Putting the i's together, I get 7i. Putting the j's together, I get negative 18j. I didn't subtract them because I know that this is the same as 2v plus negative 3w. And this value, of course, was negative 3w. And this one was 2v. And so when I put them together, I get the resultant vector that I was being asked for. So basic scalar, just basic adding, honestly, but it still is still has direction, and it still has direction and magnitude that we could find using what we talked about in the previous video. Let's take a look at the next part of your objective, but before we do that, here's your first multiple choice question for your checkpoints. So pause the video, find 2u plus 1v, add those two together and find the resultant vector, and then continue on with the video. So our next objective is to be able to write a vector in terms of its magnitude and direction. Now, when we talked about the application we were talking about, the direction 0 degrees was due north. But typically, because sometimes we'll be talking about forces on land, oftentimes 0 is going to be the x-axis. Now, the hard part is oftentimes we'll also be given direction in terms of north and south and east and west. So you'll see that in class the next day when we look at some applications, and we'll talk more about that when we're all in the room together and you can ask questions rather than in a video. But for now, I want you to understand that 0 is going to be straight to the right, just like your unit circle. So this goes back to the basics of unit circle. And our goals here are to understand first how are theta and the magnitude of v related to a and b. Now, a and b is ai, b, j. And remember, a is really describing the horizontal component of the vector, and b is the vertical component, based on our definition that we talked about in class and in last video. It's the horizontal and vertical component. So in my picture here, let's find A and B. A is the horizontal component, so it's this distance here. B is the vertical component, so this distance here. Now the question is, how is theta and the magnitude of V related to A and B? Well, we can use the definitions we already have for various pieces in this picture, in this angle. And what we already know, actually, is that theta is related to A, B, and vector, and the magnitude of V, of course, magnitude of V is the length of that right segment there, by the cosine and sine. So, for instance, the sine of theta is B over the magnitude of V. B over the magnitude of V. Because of the definition of sine, and because we're using the x-axis as 0. So by using the x-axis as 0, we actually can use our basic definitions of sine and cosine to help us relate the magnitude and direction with the a and b components of the vector. Now we'll do the same thing for cosine. Cosine is a over the magnitude of v. And again, it's all relating back to the basics of adjacent over hypotenuse. So these are basic facts about A and B, and now if I want to relate, now we'll look at the examples to understand that. So this is the number one thing you probably want to write down, with perhaps a picture, the picture you have here, relating it. Now we'll talk about how we're going to apply that in an example. We're going to write vector v in terms of I and j whose magnitude and direction angle are given. So first off, I'm going to sketch a picture, since we're beginners at this, and we're going to sketch a picture of this situation. So theta is 60. Now remember, we start at 0 is here. 60 degrees is almost to 90. that's 60. Now I'm going to draw that a little bit smaller. So this is 60. And the magnitude of V is 6, so that means the length of this segment is 6. So I really have this triangle here like this. And so I'm trying to find A and B in order to write the vector in terms of I and J. So A and B are the vertical and horizontal components. A is the horizontal, B is the vertical. Well, in order to do that, it is going to use this relationship. The sine of theta is equal to B over V, the magnitude of V. Now, I'm actually going to solve this for B, because remember, my goal is to find B. I want to find AI plus BJ. And so I actually need to find B and plug it into this formula. So let's solve this green equation for V by simply timesing both sides by the magnitude of V. The magnitude of V. Timesing both sides by the magnitude of V. So a more helpful equation is the equation that states that B is the magnitude of V times the sine of theta. That's how I'll find B. B, as in boy. Now A is going to have a similar situation. So now I'm taking this equation and I'm going to solve for A. So I'm going to slide my picture over so I can show you this a little bit more clearly. I'm going to take this equation, cosine of theta, A over the magnitude of V, and I'm going to solve for A. Timesing both sides by the magnitude of V, I get A equal to the magnitude of V, cosine of theta. These are also two equations that you will want to have memorized. And I'll highlight them here real quick. So the two equations that I would recommend getting memorized are this and this. They're of course equivalent to this, but these are probably more helpful. In fact, both of them are going to be useful because sometimes we'll be solving for one over the other. So now what does that mean about my particular situation? All I need to do is plug in what I know. What I know is theta, 60 degrees, magnitude of V, 6. Let's use this equation to find the A value. I'm simply going to plug in my V value of 6, my magnitude of V is 6, and my angle of 60 degrees. I'm just plugging in what I know, now that I have the equations that I need to solve. Now I look to my unit circle and I find the cosine of 60 degrees, and the cosine of 60 degrees is 1/2, so this is really 6 times 1/2 equals A. And that's just 3. So my A value is 3. So now when I'm trying to find, let me get this out of the way, I'm trying to find my resultant vector, it's this value, AI plus BJ. So V is 3I. And that's really saying that this length right here is 3. That's what I was trying to find. Now I'm trying to find the height of the triangle, the B value. And the B value is simply found by using now this equation. B is the magnitude of V sine of theta. So again, I'm plugging in what I know. I know this is 6. The magnitude of V is 6. The sine of 60 goes next because theta is 60. And now I look to my unit circle and I find the sine of 60 is the square root of 3 over 2. So this is 6 times the square root of 3 over 2. Simplifying that, 6 divided by 2 is 3. Square roots of 3. That's my B value. So now I plug B in for my vector form, and I get 3 square roots of 3, J. Again, that's the length of this side right here. 3 square roots of 3. So these two formulas are really all that you need in order to solve this. You don't even need to really draw a picture. You need your unit circle, and you need to memorize these two formulas that I've highlighted here. This formula and this formula. These two formulas are all you need in order to find these resultant vectors, or these vectors in terms of I and J. So let's try it again. So again, the two formulas we need are that A is the magnitude of V times the cosine of theta, and I need to know that B is the magnitude of V, the sine of theta. Memorize those two things, and you'll be able to find A and B every time. So I'm plugging 8 in for the magnitude of V. And I'm plugging 225 in for the cosine of theta. So the cosine of 225 degrees. The sine of 225. And that's how I'll find A and B. So now I look to my unit circle, the cosine of 225, and I find what the cosine of 225 is, and I do 8 times, and the cosine of 225 is negative square root of 2 over 2. Timesing these two, the 8's again cancel with the 2, I get negative 4 square root of 2. Same idea over here. Just so happens that the sine of 225 is also negative 2 square roots of 2. And I multiply that out, and I also get negative 4 square roots of 2. So my vector v in terms of I and j are v equals negative 4 square roots of 2a. I'm sorry, not a, j, excuse me. Negative 4 square root of negative 4 square roots of 2i. Negative 4 square roots of 2j. Because these, of course, were my b and a values. And that's my solution for example 2. Now it's your turn to give it a shot. Use the formulas to find the a and b values and write the vector v in terms of I and j, where theta is 30 and my magnitude is 7. And try and write your answers into the Google form. Do your best to either use SQRT for square root. So if you wanted to do square root of 3, you could write SQRT 3 in order to write that. Or you can try and find the symbols on your browser, depending on where you're entering your solutions. But do your best to answer the answers as you have, so I can see that you've tried these problems, and ask me any questions you can in the video, in the checkpoints, or in class tomorrow.